Good morning. Today we would like to explain about full up to full down ratio for an nMOS inverter driven by one or more pass transistors. It is one nMOS inverter. This is another nMOS inverter. These two are driven, this second transistor driven through one or more pass transistors. In this lecture, we have to remember one thing, that is every pass transistor has some threshold voltage that is denoted by VTP. I am applying here input to the pass transistor. I am taking the output here. We know the threshold voltage. Threshold voltage, at which voltage means at which voltage the device is coming to conduction is called, that minimum voltage is called the threshold voltage. For suppose I am applying input VDD here. This pass transistor passes the information that should be greater than VDD minus VTP. It passes the signal VDD minus VTP. This much of voltage that pass transistor transfer, that should be greater than VDD minus VTP. This VDD minus VTP is the input to the second inverter. So we can say the second inverter input voltage V inverter 2 voltage input VDD minus VTP. VTP means threshold voltage of the pass transistor. We know the VDD, it is a power supply. Okay, just you remember this one. It is the important one in this case. You remember that I am taking equivalent models for these two inverters. I am taking inverter 1 equivalent model. Inverter 1 consisting of the pull up transistor and the pull down transistor. I am taking pull up transistor as the current source. So in this one passing current I1 I am taking as it consisting of the pull down transistor. Pull down transistor I am taking as resistance. So it produces some resistance. I am taking it as R1. It is the ground terminal. I am taking output across the which one? Across the pull down transistor. The output across this one is equal to V out. I am applying across the input across this one. This is equal to inverter 1 voltage, input voltage. I am taking it as VGS. This VGS is equal to VDD. In the sense, నేను ఇక్కడ ఫస్ట్ ఇన్వర్టర్కి అప్లై చేసే దానికి ఏ వోల్టేజ్ నాకు ఇన్వర్ట్ అవుతుందండి, ఇక్కడ అప్లై చేసిన వోల్టేజ్ ఇన్వర్ట్ అవుతుంది. ఆ వోల్టేజ్ దేనికి ఈక్వల్గా తీసుకుంటున్నానండి, వీడిడికి ఈక్వల్గా తీసుకుంటున్నాను. ఆ వోల్టేజ్ ఎక్కడ అప్లై చేస్తున్నానండి? విజిఎస్ అంటే గ్రేడ్ టు సోర్స్ టెర్మినల్కి అప్లై చేస్తున్నాను. కాబట్టి నాకు నేనేమని తీసుకుంటున్నానంటే వి ఇన్వర్ట్ 1 ఈజ్ ఈక్వల్ టు ఇన్వర్టింగ్ వోల్టేజ్ ఈజ్ ఈక్వల్ టు INV1, this one. V inverting 1 is equal to VGS is equal to VDD. Okay, I am the second equivalent model for the second inverter. It is also same. It is the current source I2 for the full up transistor I am taking. Next, second enhancement mode pull down transistor I am taking as it is a ground. It is R2. The voltage drop across this one I am taking V out 2. Here I am applying the input. You guys, in this case you observe here V invert 2 is equal to VDD minus VTP. So I am applying input here VDD minus VTP. This is equal to VGS2 or V inverter 2 or VGS. I am taking this one. Then after next I am taking case 1 for the inverter 1. For inverter 1, what happened for inverter 1? For inverter 1 I am taking the say what is that called? Okay, just wait. Here I1 current is flowing. This is the depletion mode transistor. It is the enhancement mode transistor R1. In this derivation I find out the V out. V out is equal to I1 into R1. I1 taking across the depletion mode transistor current, R1 is equal to, it would be taking, we already saw the inverter in circuit. In this one it is the R1. I have to find this I1 and this R1. I am going for this one. I am taking inverter 1 for the depletion mode transistor. Depletion mode transistor, in this depletion mode transistor saturation condition. Then in this one IDS is equal to, for the depletion mode transistor, K into, it is the full up ZPU by LPU into VGS minus VT whole square by 2. So simply we can write that IDS is equal to K into mu P 2L by PD. We can write like this. Okay. Then in this case input voltage for the depletion mode transistor VGS is equal to 0 volts. I am substituting this equation VGS is equal to 0 in the above equation. What will happen? IDS is equal to K into WPU L pull up 0 minus VT whole square by 2. I am taking it as I1. So I can write I1 is equal to K into WPU1 LPU minus VT whole square by 2. So in this case for the transistor I have to find out V out 1. In this one I got the, what is this? I1 I get. Next I have to find the R1. How we can find R1? For R1 I'm taking R1 as the, for the depletion mode, sorry, enhancement mode transistor I'm taking enhancement mode transistor. Enhancement mode transistor current IDS is equal to, what is that? Current IDS is equal to, you observe here, K into It is for the pull down transistor by LPD into VGS minus VT into VDS minus VDS square by 2. This is the equation for the enhancement mode transistor current, drain to source current. If I take this as the equation number 1, if I take this as equation number 2, I would take this is equation number 3. Guys, in this equation I am taking for the transistor 1 inverter 1, I am considering this is as the VDS1, I am considering this as the VDS1. So in this terminology, in this equation, here VDS1 is common, here VDS1 is common. I am taking common from this from these two terms. Then IDS is equal to K into width of the pull down to length of the pull down ratio, and VGS minus VT minus VDS1 by 2 into VDS1. Up to now clear? I am bringing this one to which side, Nana? From the left hand side, where this right side value VDS1 bringing to left hand side. This will become IDS by VDS1 is equal to K into WPD by LPD. Please wait, sorry. LPD into VGS minus VT minus VDS1 by 2. This is the equation. I know that IDS by VDS1 is equal to conductance. Reciprocal of conductance is equal to resistance. For which one? For the first transistor, for first inverter. Then I can write that as 1 by R1 is equal to 1 by R1 is equal to IDS by VDS1 is equal to K into which one, Nana? For the pull down transistor, L by LPD into VGS minus VT minus VDS1 by 2. We know that this VDS value is very small, so I can neglect the VDS1 by 2. 1 by R1 is equal to K into WPD by LPD VGS minus VT. I am taking it as equation number 4, I think this one. Equation number 4, we know that we have to find V out. So it will become, how it will become? R1 is equal to 1 upon K into WPD by L pull down into VGS minus VT. R1 is equal to V suffix T, Nana. Next, V out 1 is equal to I1 into R1. So V out 1 will become a V out 1 is equal to, I know I1 value. What is the I1 value? K into W pull up by L pull up into VGS minus VT minus VT whole square. V out, it is the I1 value, into R1 is equal to 1 upon K into WPD by LPD. We know that VGS is equal to VDD in equation number 1. Then it become a VDD minus VT. This K and K get cancelled. This will become a, and we have to know the two more conditions. One is that 1 is equal to W pull up to L pull up is equal to 1 by Z pull up for the inverter 1. So similarly WPD by LPD is equal to 1 by ZPD1. So I am substituting these values in the above equations. Then above equation V out 1 will become a ZPD1 by ZPU1 minus VT whole square divided by VDD minus VT. Have you got my point till now? Okay guys, thank you. This is for the depletion mode transistor, so I can write this is the depletion mode transistor VD. For the inverter 1 is completed, V out 1 we got that. Next I would like to find V out 2. V out 2 is equal to I2 into what is next R2. I2 in the equation in the second inverter depletion mode transistor. Similarly I2 we can write this as like this, K into W full up to L full up to into minus VTD2 whole square or VTD whole square. VTD whole square. The depletion mode transistor. This is for the 2 equation. And we have that and R2. And this R2 we have only one difference. That is before for that I am taking, you could wait, enhancement mode transistor. Enhancement mode transistor, what I am going to find value, IDS value I am going to find value. So IDS is equal to K into W. It is for the full down, PD2 by LPD2 into VGS minus VT into VDS minus VDS2 whole square by 2. So then IDS I am taking VDS is common, VDS2 is common, and keeping here VDS by 2 is equal to K into WPD 2 by LPD 2 into VGS minus VT minus of VDS by 2. It is actually what we have to write now. Then after we subtract, we removing this one because of VDS is very small, then VDS by 2 is also very small, so we can neglect this one. Here we have to consider here VGS value consider. In starting what we said, VGS is equal to V inverter 2 is equal to VDD minus VTP. TP is the threshold voltage of the pass transistor. I am going to substituting this VGS value in the above equation after neglecting VDS by 2. So VDS by VDS2, it is equal to 1 by R1 is equal to 1 by R2. It is the reciprocal of the resistance. So it will become a K into this value we can put as 1 by 1 upon Z pull down to. This will become, what will become, how it will become means VGS minus VT, we know very well. VGS is equal to VDD minus VT. After we neglected na, VDS by 2 is we neglected because of that is very small. This will become a this way, in this way. So I have to find V out. V out is equal to I2 into R2. Then V out is equal to, what will happen, we'll see. V out is equal to, we know the I1 value. I1 is, what is the I1 value? I1 value K upon ZPU minus VTD whole square. It is equal to I1 value into R1 value. R1 is equal to 1 upon K by ZPD. This is for the second inverter, na? That's why I am taking this one. Here VDD minus VT minus, sorry, VTP minus VDD minus VTP minus VT. This is the equation. So this value and this value get cancelled. It will become a ZPD2 by ZPU2 into minus VTD whole square by VDD minus VTP minus VT. This is the V out 2. For the ratio, I am equating V out 1 is equal to V out 2. నేను నా రేషియో ఫైండ్ అవుట్ చేయడం కోసం V out 1ని V out 2ని ఈక్వల్ చేస్తున్నాను. V out 1 is equal to, actually I'll get here 2. This will also get 2. I1 R1. You could wait, guys. Actually here I missed the 2 because of in this equation I1 is equal to upon 2. So here also I will get the 2. Okay, guys. ZPU1 PD1 by ZPD1 by ZPU1 into minus VTD whole square by 2 into what happened, VDD minus VT is equal to V out 2. It is the equal to above equation. ZPD2 by ZPU1 minus VTD whole square upon 2 into VDD minus VTP minus VT. These two get cancelled. This one get cancelled. What do we have to remind? What we have to remind means we have to go for that one. Is this clear now? Okay. Just what I need the ratio. I am bringing, okay, above equation will become a ZPD 1 by, wait. ZPD 1 by ZPD ZPU1 1 by VDD minus VT. VT here, VT in the sense for the enhancement mode transistor threshold voltage. Okay. ZPD2 by ZPU2 1 upon VDD minus VTP minus VT. What I got that one. Okay. Next I am bringing this to left hand side. This denominator will become a numerator one. So next equation will be like this. PD2 by ZPU2 is equal to, what will happen? ZPD1 by ZPU1 into which one? I am bringing this one, VDD minus VTP minus VT. VDD minus VTP minus VT divided by VDD minus VT. We have some typical values. What we have to full up to full down ratio. So I am reciprocaling every one. Therefore, full up to full down to is equal to Z full up 1 to full down 1 into VDD minus VT upon VDD minus VTP minus VT. We have some typical values, already measured values. VT is equal to 0.2 VDD. For the pass transistor, threshold voltage is equal to 0.3 in VDD for the pass transistor. Here I am taking only single pass transistor. If I take more transistors, this value will be increased. Therefore, by substituting these values in the above equation, ZPU2 by ZPD2, we already measured in the equation Z full up to full down ratio, an inverter driven by another inverter is equal to 4 by 1. I am substituting 4 by 1 here. This will become a VDD minus VT value 0.2 VDD upon next VDD minus VTP value 0.3 VDD minus 0.2 VDD. It is a point. I am taking it as a 10 out. 1 minus 0.2 is equal to how much? 4 by 1 into 0.8 VDD upon, it is equal to 0.3, 0.2, 0.5, 0.5 VDD. VDD get cancelled. Then what will happen? ZPD2 by full up 2 by Z full down 2 is equal to 4 by 1 into 0.8 by 0.5. This is equal to 1.6. 1.6. This is approximately equal to 2. Round figurely, that is equal to 2. Therefore, 4 by 1 into 2 is equal to 8 by 1. So, full up to full down ratio full up to full down ratio 8:1. So simply we can say that an nMOS inverter full up to full down ratio for an nMOS inverter driven through one or more transistors should be greater than or equal to 8:1. ZPU is to ZPD. ఫర్ ది సింపుల్గా చెప్పాలంటే అండి, ఒక ఎన్మాస్ ఇన్వర్టర్ని కనుక 1 or more పాస్ ట్రాన్సిస్టర్ కనుక డ్రైవ్ చేస్తే వాటి యొక్క ఫుల్ అప్ టు ఫుల్ డౌన్ రేషియో అనేది 8:1 అనేది మినిమంగా ఉండేలాగా మనం డిజైన్ చేసుకోవాలి అనేది దీని యొక్క ముఖ్య ఉద్దేశం. నేను ఒకసారి సింపుల్గా సమరైజ్ చేస్తానండి. ఈ డెరివేషన్ ఎలా చేయాలి ఏంది అనేది సింపుల్గా డెరైవ్ చేస్తాను. ఫస్ట్ నాకు ఇందులో గుర్తుపెట్టుకోవాల్సింది ఏంటి అంటే, పాస్ ట్రాన్సిస్టర్ యొక్క థ్రెషోల్డ్ వోల్టేజ్ ఇన్ ద సెన్స్ అంతే, వీటి గురించి మనం తెలుసుకోవాలి. అక్కడ మనకి ఏమొస్తుంది అని అంటే, సెకండ్ ఇన్వర్టర్ ఇన్పుట్ ఏమొస్తుంది, VDD మైనస్ VTP వస్తుంది. ఇది ఒకటి మెయిన్ ఫస్ట్ స్టెప్ గుర్తుపెట్టుకోవాలి. అది అయిపోయిన తర్వాత ఆ ఇన్వర్టర్స్కి వచ్చేసరికి ఈక్వలెంట్ సర్క్యూట్స్ డ్రా చేసుకోవాలి. ఒకటి వచ్చేసరికి ఏంటంటే కరెంట్ సోర్స్ ఫుల్ డిప్లేషన్ మోడ్ని కరెంట్ సోర్స్గా తీసుకుంటాం. దాన్ని వచ్చేసరికి నెక్స్ట్ రెసిస్టెన్స్ వాల్యూ తీసుకుంటాము. అది అయిపోయిన తర్వాత రెసిస్టెన్స్ వాల్యూ తీసుకున్న తర్వాత ఫస్ట్ సర్క్యూట్కి Vout1ని డిరైవ్ చేసుకోవాలి. అదేంది I1 అండ్ R1. ఈ I1 అనేది ఎక్కడి నుండి వస్తుంది, డిప్లేషన్ మోడ్ ట్రాన్సిస్టర్ని ఫైండ్ అవుట్ చేస్తాము. ఈ R1 అనేది ఎక్కడి నుంచి ఫైండ్ అవుట్ చేస్తాము, ఎన్హాన్స్మెంట్ మోడ్ ట్రాన్సిస్టర్ని ఫైండ్ అవుట్ చేస్తాం. సేమ్ యాజ్ ఇట్ ఈస్గా నాకేం చేసుకోవాలి, Vout2 ఫైండ్ అవుట్ చేయాలి. అప్పుడు ఏమొస్తుంది, I2 ఇంటూ R2 వస్తుంది. I2లో నాకు డజంట్ చేంజ్ అండి, ఇందులో ఏం చేంజ్ ఉండదు. R2లోకి వచ్చేసరికి ఏమొస్తుందనంటే, నాకు చేంజ్ ఎక్కడ వస్తుంది అని అంటే, ఇక్కడ R1 దగ్గర ఫైండ్ అవుట్ చేసేటప్పుడు నేను ఏం చేస్తాను అని అంటే, అక్కడ ఇన్పుట్ వోల్టేజీ VGS ఏం సబ్స్టిట్యూట్ చేస్తాను, VDD సబ్స్టిట్యూట్ చేస్తాను. ఇక్కడ ఇన్పుట్ వోల్టేజ్ ఏం సబ్స్టిట్యూట్ చేస్తాను, VGS VDD మైనస్ VTP సబ్స్టిట్యూట్ చేస్తాను. అంతే, అంతకుమించి ఏముండదు రెండింటికి తేడా. దీన్ని సబ్స్టిట్యూట్ చేసిన తర్వాత Vout1 Vout2 వస్తుంది. నెక్స్ట్ ఈ రెండింటిని ఈక్వల్ చేస్తాను. Vout1 ఈజ్ ఈక్వల్ టు Vout2 చేస్తాను. Vout1 ఈజ్ ఈక్వల్ టు Vout2 చేశాను అనుకోండి, నాకేమొస్తుంది అని అంటే రేషియో వస్తుంది. దట్ రేషియో ఈజ్ ఈక్వల్ టు ఇది. ఈ స్టెప్స్ ఇలా గుర్తుపెట్టుకొని కనుక మీరు డెరివేషన్ ప్రాక్టీస్ చేస్తే ఈజీగా ఉంటుంది. ఇందులో కనుక ఇంకా ఏమైనా డౌట్స్ ఉంటే కామెంట్స్ రూపంలో పోస్ట్ చేయగలరు. ఓకేనండి. థ్యాంక్స్ ఫర్ సబ్స్క్రైబింగ్ మై ఛానల్.